Welcome to today's very exciting event. My name is Xiaohu, and I'm an associate professor in the Faculty of Education here. Today is my pleasure to host this event. And as you know, this is a hybrid event. We have audience here and even more audience online. So then, as we know, this public seminar is jointly hosted by our Faculty of Education and also the Center for Information Technology in Education, CITE. And this is the first seminar in a series of seminars that will be hosted by CITE in 2023. So before we begin this seminar, I'd like to invite the director of CITE, Dr. Gary Wang, to give us a few words to welcome everybody. Dr. Gary Wang today is joining us online. So Gary, please.
Hi, everyone. I hope you can hear me. So, the transmission is okay, right? So you can all hear me? Great. So my name is Gary Wang, and I'm the director of the Center for Information Technologies in Education. And today, this is really my honor to welcome you all, and particularly welcoming Professor Dragan Gašević, distinguished professors in the learning analytics at the Monash universities, and this is really our pleasures to be able to host you in our centers. And as you all know, that our Centers for Information Technology in Education is in its 25th years of operations this year. And so our vision statement, empowering communities and transforming learning, continues to guide us in our aspirations to be a centers of excellence and as a focal point for collaborations in innovations, and providing a platform for individuals and institutions and dreamers and experts to come together and build new knowledge. And so today, as the first seminars series we are organizing throughout this year, we hope that you all will feel the excitement of having these knowledge exchange and also the collaborations in research and discussions and debate in these particular topics. And so without further ado, I'd like to thanks everyone for coming, and also thanks Xiaohu for bringing Professor Dragan Gašević to our campus. And also I look forward to being able to meet each one of you in person very soon. Thank you very much, and enjoy the seminar.
Thank you, Gary. Now, it's my great pleasure to introduce the speaker today, Professor Dragan Gašević. Professor Gašević is a distinguished professor of learning analytics in the Department of Human-Centered Computing of the Faculty of Information Technology, and the director of the Center for Learning Analytics at Monash University. Dragan's research interests center around data analytics and design methods that advance understanding of self-regulated and collaborative learning. He is a founder and served as the president of the Society for Learning Analytics Research. Yeah, which I'm wearing the uniform today. Very honored. And he also held several honorary appointments in Asia, Australia, Europe, and North America. He is a recipient of the Lifetime Member Award as the highest distinction of the Society of Learning Analytics Research, and a distinguished member of the Association for Computing Machinery, ACM. In the past 4 years, he was recognized as the national field leader in educational technology in the Australian Research magazine that is published annually. So last but not least, Dragan led the European Union-funded SHELA project that received the Best Research Project of the Year award in 2019 from the Association for Learning Technology. So those are just a few honors that Professor Gašević had garnered in the past years. Without further ado, we welcome, let's have a round of applause to welcome our speaker today to give us a talk on direction for dealing with ugly truths about learning analytics.
Thanks so much for the honor of the invitation. I'm really pleased to be here in Hong Kong, back after 3 years. My last trip before pandemic was Hong Kong. Obviously not the first since the pandemic started kind of getting towards the end, but I'm really excited to close this cycle of coming back to Hong Kong where we can continue with more or less normal lives. I'm really delighted to talk to you about learning analytics and about some of the things that are happening in learning analytics. As I'm talking today about many different points, I'm not going to be specifically naming any particular names, but I want to thank many colleagues who work with me in the Center for Learning Analytics, about 40 regular core members and about another 30 to 40 affiliates, plus many other international collaborators in a number of different projects that are working with us. So just lots of appreciation for all their contributions that I'm going to be talking about. Just going back to the roots of learning analytics, in some of the early days of before we even knew what SOLAR was and learning analytics was, a group of several people realized they were doing things that were independently done on a very relatively related topic. And the idea was that many people were excited about digitization in education, use of different types of technologies. But at the same time, we had no idea what is going on when we use some of these technologies. At the same time, we also realized through different types of modalities of both technology as pedagogy, our classrooms are changing and they are increasing the complexity of the classrooms. And therefore, it was not quite clear whether some of these things are effective or not. And many of the feedback loops were lost in many cases, especially if things are happening online. We all had that first-hand experience. So it was really hard to know what's going on behind these type of things. And even beyond nodding in this physical classroom, I don't know what is really going on beyond. So that was really always the kind of the ultimate goal of learning analytics. And to articulate in one sense, the specific goal of learning analytics is to close the loop of data, starting from the data collection and understanding what is happening inside of that data through different types of analysis to have some form of models that are coming from a range of different disciplines, coming from data science, machine learning, statistics, network science, you name it. The idea is to try to extract certain types of insights that are informed, and they are also going to inform relevant educational theory, so that we can then have something that can lead us into the transformation of our practice. And then again, collect the data about that change practice and see the extent to which these transformations have any impact. So in a nutshell, this is a cycle that can go into a spiral. You can have as many cycles as you want. So in a way, you can also call it a continuous improvement loop that learning analytics aims to offer. So it's been now more than 10 years since we started the field of learning analytics. By the way, we kind of officially think about learning analytics that started in 2011. That's when we had our first Learning Analytics and Knowledge Conference in Canada in Banff. That was the very last day of February at -35 degrees, and we all enjoyed it. But at the same time, you learn lots of different lessons that we are actually having to think about in learning analytics. And I'm going to try to reflect on some of these lessons as we are, as a field, are moving forward and thinking about the use of analytics. So I'm going to be having lots of these different types of lessons, and I will call them ugly truths. And I want to also give you immediately now some of the key takeaways. So if you actually get bored in the middle of my presentation or have to run, at least you got 3 key points that you can take away from my talk. So the first one is that data that we use in learning analytics are not flawless. And in many cases, they are really an afterthought, rather than it's something that is purposefully collected and then also used. Often is the principle, oh, we have some data, why don't we try to use it and see what happens? And that's already in many cases a bit too late. Another critical point is that we get lots of excitement about the applications of data, funnel these type of data. Recently, we really lived the hype of AI with ChatGPT, and in a way, it's good that demonstrates what's possible, but also doesn't reveal what is not and what are the other issues that we are going to experience with it. So the key point is that we need to carefully use these different types of applications of AI to education, so that it is primarily first inform what we know about education, so it can also meaningfully inform education and have some impact. And the final thing is that we often think that analytics is a technical bit that we need to do. Get some data, crunch the data, create some like nice little dashboards, and then people are going to use it and the magic will happen somehow mysteriously. But we often really try to hide the complexity, socio-technical complexity under the rug, and thinking about that magic would somehow mysteriously happen. It doesn't happen easily. So that's the really thing. If we want to have impact, we also need to account for that complexity. So just a quick disclaimer before I dive into the rest of my talk. This will be a relatively condensed thing. So if I don't mention some of your favorite topics, please raise that question. And I'm going to also be happy to engage into the conversation both at the end of this session and also during the session that we will have later in the afternoon. So for the rest of my talk, I'm going to be going through these three steps that I mentioned that are creating the loop of learning analytics. I'm going to be discussing about data. I'm going to be discussing about models. And I'm going to be talking about the transformation bits that are related to learning analytics. My featured list of today for these ugly truths about learning analytics is that we're going to first start that our data sets are relatively small, that we don't necessarily have so many data points as many think that we do, and also that we have a fair bit of issues about validity and reliability in the measurements that are related to learning analytics. So you can ask me, how do I mean that our data sets are small? I mean, since learning analytics start from the premise that we will have this big data, and then based on this big data, we will make a huge transformation. Well, let me give you just a very simple one example, and you can find many of those examples. Is we have this paper in which we analyze the students who are retaking the MOOCs in the context of some of the Chinese MOOCs, and we basically they were primarily related to professional development of teachers. And we had basically this MOOC which was offered several times, and we had about 100,000 students who took that MOOC, but we identified only about 300 students who were retaking that MOOC, and we want to understand the reasons and the ways how they are retaking these MOOCs. And then we collected these digital data about that. But when you think about that data, for these 300 students, we only collected about 180,000 data points for them. Or if you think about that, that's basically only about less than 90 events per week for each of these participants. And if you account that most of these events are login events, how much meaningful insight can you get from this type of data about what is happening in terms of learning? All right, but somebody say, well, but we have many of these courses, so we just basically combine these data sets and the problem's solved. Well, not that easily done, as you may think. This is just basically one of the early studies we did in learning analytics, which tried to understand the impact of the design complexity that is happening across many different courses that you may have in learning analytics. And so this basically demonstrates 9 different courses. They all are using different types of functionalities of the tool because they are supporting different types of tasks that were envisioned in the pedagogical intent behind some of these courses. And therefore, combining these courses together will not really give you much more deeper insight. It'll just basically increase the complexity of the types of analysis that you need to do. So what is our direction? I mean, well, we will not increase necessarily this and solve this problem of the contextual diversity that is happening across many different courses. But what we can do is, and we should be doing far more, is to capture the type of data that are describing the context in which that data was collected. Simple things that could actually tremendously help us automate some of these analyses and scale up the impact would be we can the pedagogical metadata inside of, say, your favorite learning management system that kind of tells when a particular activity was scheduled to happen, or what was the pedagogical purpose of that particular activity, and simple things like that. So we don't have to invest huge amounts of efforts into these type of things, they happen at the time of the creation and the design of some of these forces, yet they will tremendously be helpful for our down the line analysis of things. The other point I'm going to say is, and that's quite consistent with the first premise, is that our data points are not necessarily frequently sampled. In many cases, we depend on the type of data that are typically collected inside of the online learning environments. And these type of things are really kind of trying to think about clicks. But do these clicks come for learning? Do they represent really meaningful learning points that are happening behind the things? And also, what happens between these clicks? Because sometimes it may take like 10 or 20 minutes between these clicks. So do learners read between those 10, 15 minutes? Do learners write something? Do learners do nothing? Or they just go and have a tea or something else? We don't know in many of these cases. And we need to basically fill the blanks for some of these missing data points and understand what is happening, provided certain types of questions are relevant. I study self-regulated learning, so I'm really interested to have far more granular traces about what students are doing in that process. So what is the critical direction that we are taking and many are taking is to think about the multimodal data, that we can actually collect far more in terms of the mouse movements, in terms of the keystrokes, also thinking about eye tracking. Sometimes you may ask the learners to turn the cameras on to get certain understanding what's going on. And also at the same time, have the privacy protection of the learners when you're collecting the eye tracking data. That's really critical. What we've done so far and our results are showing, and I'm going to also mention a little bit later, is that we are getting far more granular and better insights into the students' patterns of self-regulated learning and the ways how they are managing their overall learning process. So we can get far something more interesting that is also theoretically grounded. And at the same time, learning is happening just in the online spaces. I mean, we are in a physical space. And so this multimodal data, and this is an example of one of the projects that we are working in the Center for Learning Analytics at Monash, in which we are actually looking into the simulation-based learning of the nursing students. And we are seeing this highly instrumented room that is trying to track the students' teamwork, where we are collecting the data about the locations of the students, which, for example, beds students are attending to, whether that's really the urgently important task or that's a secondary task that they are actually paying far more attention. We are collecting the data about what they are talking about. We are also trying to get the physiological data about what is their level of stress when they are engaged in some of these things. Also, in some of these simulations, they are using mannequins. So how are they interact with these things? And we have the digital data about that interaction. So that gives us far more comprehensive picture in terms of what is happening in a physical space, which we can then use to turn it into deep feedback, and then can be used in a debrief session after that type of a simulation and offer almost immediate feedback to the learners as well, what they can pay attention to in the future. The third ugly truth about the data in learning analytics is that our measurements are not necessarily valid and reliable. I already mentioned that we have all these clicks, but I mean, the meaning of these clicks is pretty unclear. What is the meaning of me hitting a certain page 100 times or 5 times? I have no idea whether I'm confused, I'm just anxious, I'm very motivated and pedantic, but I know how to stop when I actually understand something and I'm now overlearning and basically wasting the time on certain things. So there could be many types of things that we don't understand what is happening behind the scenes. So this is one of the key directions that we are seeing in the field of learning analytics. Group of authors led by Alyssa White, they proposed in 2010 for collaboration analytics, and we slightly also revised that version of the model to actually think about going from data to constructs, because we are at the end of the day interested in constructs, whether that construct could be collaborative problem solving, creativity, you name the construct that you are interested in. But basically what we have at the moment, and I discussed so far, is primarily how we can have certain data points that are computationally detectable. But then going from that computationally detectable to something that humans can also observe. And that could be, for example, in certain types of coding models that you might use in your qualitative research of education. That could be like trying to code for certain types of interactions, whether students are asking questions, whether they are sharing information, or they are also back channeling in certain situations and so on. So those are the kind of human observable, if you wish, indicators. Then we are going to the step up and we are thinking about certain sub-constructs. And that's already getting us into the realm of latent constructs, something that we theorize that should be there, but we really cannot directly observe it. Like, for example, certain aspects of metacognition. It's a latent construct, right? Or certain aspects of the social interaction as well, which could be a latent construct. And then finally, combining all these latent sub-constructs into one big construct, like, for example, collaborative problem solving or self-regulated learning, and so on. So this is really one of the generalized directions that we think about. But even then, what can be done, even if we collect all these beautiful, rich multimodal data I was talking about, we still do not understand the intent behind some of the students' activities. We don't understand why students are moving the mouse over a particular area on their screens. That's not quite clear in many of the cases. So this is one of the directions we've taken in a project that we work with colleagues in Germany, the Netherlands, and the UK called LoRa project. And we are actually trying to create also these, we call them pedagogically valuable, but also implementation tools. They're giving us some useful data. At the same time, we are also doing something that supports students' learning. So our instrumentation tool that we've been working on, it's really an extension of Moodle with another open source technology, which is called Hypothesis, which allows for annotation of the learners so they can get the highlights, comments, and all sorts of other annotations. And we are collecting all these types of data, and yet we are also adding additional tools for them, like they can see how much time they are spending on certain tasks. We also are allowing them to plan their learning in the form of a checklist. And then yet we also all the time are tracking what they are doing. And I'm going to talk to you a little bit about that later. We are also having scaffolding tool as well that kind of gives them certain real-time feedback that can be happening for them. So this is one of the types of things that gives us some more insight. Another type of things, this is the work that I did with a colleague. I think we spoke also to use pre-pandemic times at the larger Florida and University of South Australia. And the idea was that basically upon every activity the students would be completing, whether it's in the physical space or in the online space, you ask students for just a single click on a 2D canvas. And that 2D canvas would have two dimensions. One would represent, for example, the level of cognitive load, and the other one would represent the level of self-efficacy, how confident they felt that it would complete the course. And yet that data point would be then very valuable for us because we can make the interpretations. What was going on when students were doing that type of activity? And for students, that data point would become a bookmark. They can easily go back to the places they felt really not so confident, and they also had trouble to understand certain things. So they can additionally improve the planning of their learning. So what we also need to think about often is we collect all these data. We have all these instrumentation tools and multimodal data, but we really still don't have really good ways to validate whether we are measuring what we actually intend to measure. And the direction that we are thinking about and we are actually starting to develop is to use other data sources, that can actually help us for validation of our measurement. So here's the direction we've been thinking about for measuring of self-regulated learning with all these fancy row trace data that included mouse movements, keystrokes, eye tracking data, everything else. So they created one data set for us. We call them these row trace data. We also had the audio recordings of students' think alouds. And so we wanted to use these think alouds to help us additionally validate our measurement protocol for self-regulated learning that was basically using these all these rich digital data. So what we did is basically we used the same theoretical model of self-regulated or both of these sources of data to help us basically extract the processes of self-regulated learning. We were interested, for example, in the processes such as metacognitive monitoring, metacognitive evaluation. We were also interested in the side processes as organization, what they were doing, or more also cognitive type of things. And then for the digital trace data, we created certain patterns or the rules that would actually analyze digital data automatically and extract certain things. And from think aloud data, well, good old manual coding of the think aloud data, and then basically spending months of doing that work to actually get us to that point. Then we would look into the alignment by basically aligning the timelines of these two data streams and seeing the extent to which they would match. But then we would also do additional small thing. We would also use these think aloud data to see whether our initially theorized rules for extraction of the processes from the digital data were applied or not. And then we would improve these rules as well from these qualitative data. So we can actually get much better, basically, insight into some of these SRL processes. So what we can actually say is that eventually, which is obvious as well, is the alignment between two is actually happening at a much better rate once we actually have these two adjustments that I was just talking about. But it is also important to say that we need to think about this alignment as well, and that these different data sources, they represent also different types of the reality. For example, think aloud data are very much dependent as well how much students have the repertoire to recognize something is important into what we are interested in. At the same time, some of these movements of the clicks, etc., they are capable to recognize other types of the reality. So we cannot say that the think aloud data is the gold standard or the trace data is the gold standard. There are these differences that we need to appreciate and recognize. All right. So these are some of the truths that I want to talk about data and what we need to think about that. Now I'm going to the bit where we want to crunch this data with the coolest, fanciest algorithms that are coming from computing or statistical research. And some of these things that I want to talk about, this first one is the generalizability of these models is really limited in learning analytics and general education, that we are really obsessing about the accuracy of these models, but we really don't measure much bias that these models have. We don't really focus much on causality of our inferences between these models. We just look into the correlations. And we really don't consider so much sufficiently explainability of these models. That is to say, how those who are not necessarily the experts into the creation of these models, but not the experts, get insights why certain decisions or inferences were made by these models so that we can make certain decisions. So when I say generalizability is limited, I've been talking about this issue for many years now, but the key thing is here to recognize back again the same thing I was mentioning when I was talking about the data as well. First one is that the instructional conditions share the results of our analysis. So for example, if we have all these different 20 courses, all having completely different learning designs, when you lump together these data, the most common predictor you will identify will be the number of plugins. And that's not particularly meaningful to inform any teaching or learning practice. That is to say, you're just going to get the most often just the least common denominator. The other more recent work that we showed is basically when you're trying to collect the data across many different courses, which share in principle the same nominal of learning design. In our case, we were looking into the problem-based learning of the medical students over the course of 4 years of their studies. We found basically that some of these typical indicators that we would be looking at that are coming from the analysis of students' activities, like regularity of their study, the way how often they study on a weekly or daily basis, and also other patterns that could be emerging from the data. And then we also looked and used these mixed effects models that could also model the random effects to actually explain us the extent to which the data that were randomly due to the student being in a particular course were also explained. What we found is that these random effects explain almost entire variability of the outputs. Not entire, but about 60%. And only we would explain these regular types of variables that we are using as fixed effects in terms of the prediction of the student's performance, about 8 to 10%. So not much. So what that tells us is basically that we do not account well for the individual differences that are happening for the students, but rather that we can only talk about the population level insights. Yet, if you're trying to do at the individual level and trying to provide guidance at the individual level, these type of models may not work so well. So what is the direction that we've been thinking about? Is to think about analytics of the learning strategies. That is to say that we want to get the unique signature of every student as they are going and doing certain types of things. Initial, our work has been so far is to think about not necessarily each individual and their unique signature, but instead to think about more like subgroups of the learners who are sharing relatively similar strategies. That is to say, we are trying to look into their temporal traits, how they are going from the login to looking into particular type of reading materials, to certain type of problems that they have to work as part of their curriculum, and so on and so on. And then we would try then to cluster these similar traces that students would have over the time. So what that tells us interesting is that these findings are relatively consistent with some of the theories, like for example, work on approaches to learning. And many of these strategies, we basically looked into the changes and the extent to which we can see whether they are applicable across many different contexts and they can be generalized. And in principle, we can find regularly 3 types of strategies that students are using. That it reminds more of a deep strategy, more shallow strategy, and the third one is more like the achievement that combines the elements of the both of them. So this is really number one interesting. And the other one is it's really well predictive of the academic performance, explains that academic performance really well. But what we want to ultimately think about, and people like Phil Winnie in Canada, and also some people who are taking much more seriously about that, is that we want to get to the level of the models of individual learners. And some of these modeling approaches are called idiographic models, meaning that we want to have large amounts of individual data and create the models for each individual learner so we can get far more better prediction and descriptions of what's going on for the individual learners. In that way, also addressing some of the concerns that are coming out of the research in both psychology, but also in education in terms of the problems with the replicability. Work that is done by Mohammed Sakar, so he's really, I think, at the forefront of some of this work in terms of looking all the idiographic approaches and the identification of individual signatures of learners. The second point, or second ugly truth about models, is that we really have a big obsession about the predictive accuracy. We want to get our models to be 100% predictive. That's not good. When it's 100%, we know that something fishy with the model is 100% predictive. But we want to get as high accuracy as possible. And in principle, there's nothing wrong with it. You really want to be accurate, and the broader literature that's called you want to be reliable. That's perfectly fine. But what is the behind that accuracy as well is that we have the data that are often representing certain structural biases that exist in our societies as well. That certain groups are less or more represented in particular types of things, or that certain types of pedagogies are more represented than others. And also that certain processes are more represented than others. So we recently got a paper published accepted for publication that basically looked into the bias that is existing literature looking inside of these models and the ways what that bias potentially can be related to. So there's a number of different types of protective attributes that could be related to that bias: gender, sex, race, ethnicity, geographic region, age, disability, first language background, income, and different types of socioeconomic status areas. So you can see that there are many of these studies that are now emerging. They're looking at the detection of some of these bias that they potentially exist. And when I say that biases, for example, model for boys will be more accurate than the model for girls. That's what I mean with the bias in this particular case. So what can we do about it? And research is also emerging in learning analytics, is that we are looking into different types of metrics that could be used to help us to measure bias. And these metrics basically can just, check across these groups whether there's equal accuracy or not. But there are also a bit more advanced metrics like ABROCA that is proposed in 2019 in the learning analytics community, gaining more attention, that is actually using two or a number of different groups and trying to compare their areas under the curve for those who are a bit more technical and trying to get that kind of difference or not between the predictive accuracy of these models. So I think we need to, in addition to the prediction accuracy, always report as well the extent to which we can detect certain bias in our data as well. And I hope over the time as well, given the importance of fairness in education and social justice, that we need to always report this type of data as well. Some of these approaches that could be used to address the bias in our models is, and we've been looking at some of these approaches, is to try to balance our data set. So there are techniques that can basically, in simple terms, oversample or undersample certain categories of the learners that are under or overrepresented depending on the problem. They could be done in many different ways, and that's basically an emerging area. Some of our research show that when we use these type of techniques, they can really improve the fairness and in some cases even the predictive accuracy of the models if they are well addressed. The other thing is also that we live in the time of the hype of ChatGPT, but we also did some research on these large language models, and they contain bias as well, men versus women. Sorry if I'm using gender as a binary in this case. So in many of these type of things, we are actually seeing that bias. And if you use that kind of big pre-trained language model, down the line of what you want to use these models as well for, you will actually propagate it bias as well. So we can try to address some of these bias, and we did some of our research as well in the analysis of normalized instruction education textual messages, but we don't know about GPT, the technology behind ChatGPT's bias behind it, because the technology itself is not as open as we would like. In our research, we use some of these other large language models that is called BERT, and in which case we could actually far more transparently analyze some of these things. So this is one important thing. It's going to be affecting us all. It's already affecting us, but we also need to get more transparency around that thing. And the final fundamental challenge is when bias will be removed at all. Bias always exists. I stand here and I look at it from my viewpoint, and that's it. And I have all sorts of biases. So we need to embrace that bias, but we need to be upfront with that bias as well in our predictive modeling as well as our analytics data. In a similar way as qualitative researchers have been doing for many years, and they have their very well established methodologies, how they are dealing with these type of issues. And I think we need to be learning from it. The third ugly truth about the models is that we really have much more focus on correlations, meaning we are creating predictive models and trying to understand what are these predictors of students' output. But I really do not often do much work for many of the researchers in the field that can directly tell us whether a certain thing happened because of certain timing or certain intervention. Even one of the most well-known studies of the work that was done in 2012, published at least at a conference, which was basically using this core signals study that was done at Purdue University, made really significant causal claims where they really didn't have experimental designs, nor the analytical methods that could actually make these causal effects. We really need to think about the methods that can model causality. In more recent work we just published, we looked about some of these acyclic direct graphs and the ways they can be used for model causality, but there are many other also approaches that are available in the learning, in the broader data science field that could be used in the kind of statistical research, as well as thinking about methods that are related to the experimental designs that you need to have to get the type of data that can actually help us to make causal inferences. The other thing is more related to the work that we ran recently as quantitative ethnography is that we need to think about much closer interaction between predictive modeling and data scientific work with the qualitative work. So the work done by Ryan Baker's group at University of Pennsylvania, where they are actually looking at the predictive models that can then help them identify students who should be interviewed in real time, so they can get the reasons behind some of their anxiety type of elements. Then identifying students who have high level and low level anxiety then feeds back into the models and the explanation of these models, why certain patterns of the students' strategies were detected in the online type of space. So we really need to think about these type of things so we can get much more also causal impact in the form of new mixed methods that could be and should be developing in this broader field. Final thing I want to talk about, the modeling part, is the explainability. And we need to think about explainability as essential for education. Why am I saying this? Because we don't see huge uptake of the adoption of deep learning technologies that made a huge fuss in the broader field of artificial intelligence in the last 10 years, and especially they are bringing about all these important headlines in the last several months. In education, why? Are we incompetent to use deep learning? In most of the cases, we know we can do that. But what we do also require in education is that we can explain why certain predictions were made. What were the cause reasons why students are, for example, failing to complete a particular activity, or what led learners to have certain types of problem-solving strategies that they were working on certain types of tasks. So that's one of the key reasons. But I think one of the key things is for us is that if you don't engage deeper into deep learning research in artificial intelligence, you're also going to miss a lot in that space. And also many researchers may get a surprise with the kind of how come this like GPT, or how come it cannot explain why it's making certain inferences or behaving in a certain type of things that we are seeing there. So we need to really identify when explainability is needed and when it's not. One obvious case when that explainability is not needed is if I'm doing transcription. So if you look at me and you are using basically auto transcription software, and if you basically see that it's matching what am I exactly saying, well, it's fine. You can trust that technology and that's fine. But in some other cases, if you're trying to explore what are the linguistic properties of certain verbal conversations between the people that are really leading to more or less successful collaboration patterns, then in those cases, you really want to have the explainability. So that's the kind of thing and type of work we need to do in learning analytics that can get us more. This is the direction we've been thinking about, and this is the framework we proposed recently that kind of tells us how we can approach that explainability in learning analytics. To think about who are our main stakeholders, which is a common thing we always think about in education and design-based research, but at the same time also we need to consider what are the potential pitfalls of the models that really need to be used or that we are using that are maybe necessarily complex or they are inaccurate, incomplete, etc. And also what are their benefits that these models should enable? Should we support better the agency of our learners or student-teacher interactions, etc.? So we need to think about that interplay between these different types of things, and then about the design of the tools as well. They need to support and the kind of approaches that eventually that should be used for presentation of the insights that are coming from the data, and then thinking about also the types of models from AI that could be used. So this is the broader overall picture. We also in this work as well outlined this through 3 large studies that are coming from 3 different labs. So you're welcome to engage into this work a bit more, and I'm happy to have further conversation about that. Final part of my talk today is related to transformation. And 4 Dragan's ugly truths for today is number 1 is that needs analysis is insufficiently performed when we are trying to create certain tools of learning analytics. Analytics is also not an impartial black box to outsource accountability. yes, this is beautiful technology, it's always fair, and learning analytics, we basically just always need to trust. It'll solve all the problems. We also have really limited understanding on understanding about the effects of analytics on stakeholders. And the final thing is that complexity that is related to social and organizational issues is really shaping the adoption of learning analytics, and impact is going to have. So let's dive in. So when I say needs analysis insufficiently performed, only 4 or 5 years ago, there was a systematic review of the research on student-facing analytics-based dashboards and recommender systems that demonstrated that about only 10% of the studies that were published had a proper needs analysis. Meaning, technology developers just decided what has to be developed, and they did. And they were then wondering why nobody is using some of these technologies, or they are not getting the effects that they were expecting to have. That resulted also in some of these dashboards that could be harmful. Randomized controlled trial published in 2018 by Stanford University demonstrated that the dashboard that they created that would provide students insight into the difficulty of certain courses and the workload, and randomize the students into those who were strongly recommended to use the dashboard and those who were just informed about the existence of the dashboard. The group who was strongly recommended had a negative effect on their GPA. So we need to think about some of these things. Direction, and what we are seeing in learning analytics is that participatory and co-design is gaining a lot of momentum. If you try now to publish in learning analytics and you just kind of dump on them a dashboard without the design process as well, it's not going to apply. I think for a good reason, but I think that approach also needs to be involved into the practice, not just that researchers are doing these type of things. We need to make sure that that is actually gaining momentum in practice as well. Just one simple example of what we came out during the pandemic. We've been all Zooming a lot, creating lots of breakout rooms for our students, but we would have a limited number of tutors who could actually monitor all these breakout rooms. And so we wanted to create a tool for them that could actually assist them to understand what is happening in 20 different breakout rooms at the same time. And so we then engaged and created in this co-design type of approach, which would initially identify just the questions that the teachers would have in these type of environments. Then think about how these questions could be validated with them and whether they are indeed those questions. Then try to again co-design with them the type of visualization for them, but not in a way that the primary purpose is providing the charts and the numbers, but more also to create a narrative. In our case, this narrative was around the questions that they wanted to have and to give them the answers to these narratives. And what we find also from the literature in information visualizations is that people do not necessarily are interested in making decisions only on the facts, but much more around the narratives that are shaping what is happening around them. And this is basically what we are finding at this stage. It is gaining lots of traction from our teachers. Yet there are certain other factors that are important to consider, like, for example, visualization literacy. We still have certain visualizations, and teachers who have different visualization literacy levels are actually experiencing this differently. Number two, truth related to this, analytics is not an impartial black box. And so that if you use analytics, it's not an objective decision-making engine. I just spoke about the bias that is there. Many teachers would often think, oh, well, I just outsource the assessment or even analytics to some third party. Surely that third party is really well-designed tool, which will give us impartial decisions on the many things. But you need to think about it. Sorry, but that's not the case with learning analytics. And the important question we need to think about that inside of that process is, who controls the decision-making process? Is it the machine or the humans? And how we should be approaching about that balance between human-driven versus data-driven or machine-driven decision-making process. What needs to be automated? What should be automated? What should not be in any cases automated? What we think about that, and we've been building more in our group, is direction about the human-centered artificial intelligence, the vision proposed by Ben Schneiderberg, who is one of the leading researchers in human-computer interaction. First is that we kind of need to flip this kind of thinking that in narrative and AI research, which basically said that in learning analytics as well, a human in the loop. Well, in education, in our classrooms, teachers and learners are always in the loop. Why they should be again included into that loop instead of AI? I guess AI and analytics should be fighting for the place in the loop rather than the people who are already part of that loop. That's really more kind of a side point I want to say, but this is really important direction to think about that. Schneiderman basically suggests that there are generally two dimensions we need to think about that. The extent to which we have high and low level automation and also control in terms of high human control or machine control as well. And there are generally 4 quadrants. And what he is basically suggesting is that if you want to have high level of human control, which is really desirable, and also high level automation as well. So some of these things could be related to, for example, examples that are coming from the elevators as well. There's lots of automation there. You don't want to know every single detail, but at the same time, in many cases, you can just do open door whenever you want. And so that's really quite important to understand that level of human control and the level of also automation. Those are the questions. We don't have answers in learning analytics, and we need to think about, especially as we are coming forward. This is just an example of the sampling tool for self-regulating learning that I've spoken about at the start. This tool aims to basically provide the learners with certain recommendations. Sorry if the font is too small. So it's going to give them a certain directions, what they can do. Like, for example, check the rubric, edit your essay, check the learning goals and instructions and so on. They can pick up these recommendations, create their own checklist of the things, put in there whatever they want out of them. And the key thing is here to think about the process of this hybrid human and AI regulation process, where you have always human to have certain level of control and responsibility for their learning, while AI can also offer certain types of activities for them. And we don't understand what is the right dosage of one or the other. And I bet it's a very contextual thing, as well as will be many things in learning and education. The other thing that's important is that we need to think about novel human-centered design methods as well. I just mentioned this approach that we've been breaking on that was related to human-centered approach for designing dashboards, which is question-driven. And we need to think about more different types of approaches as well as we are thinking about the implementation of learning analytics. Third, ugly truth about the transformation is that we really don't have sufficient understanding of the analytics effects on stakeholders. So what I'm thinking about here is we don't understand really how the stakeholders make sense on data about equity, diversity, and inclusion. We don't know whether we are just perpetuating bias for that, or we are actually doing some good. We really insufficiently understand that. The other thing is also, we don't really know when certain elements or insights are detected, who is responsible to take action. When the teachers are seeing certain systemic problems in their classrooms, who should take charge of it? Or even more important thing is like, not more important thing, but more something that is closer to home, is many institutions were trying to create these programs for student retention and analytics to help them to identify students who were at risk. But then, who then takes responsibility to assist these learners when the students are identified? And how that process is managed. The final ugly truth that I'm going to mention today is that social organizational complexity completely shape adoption of learning analytics. In this project that Shao mentioned at the start of my talk, Sheila, we've been working on the framework that would really try to help higher education institutions to adopt learning analytics systemically. And the framework basically started from an existing work which was aiming to create certain scientific knowledge into policy. our idea was to start from these 6, in their case, steps, we transform into the dimensions by initially thinking about mapping out the political context. And that political context could be high-level politics, but could be also small-level politics as well that is happening in our schools or our departments. Also thinking about stakeholders as well, thinking about what do you want to achieve with learning analytics, thinking about engagement strategy or enactment of that new change that we want to do. We also want to understand what is the capacity that we have inside of our institution and in our school. And then also we want to think about how we can monitor the effects of the change and learn from some of these changes as well. And then for each of these dimensions, we basically collected also 3 key elements. What are the typical actions institutions are taking? What are the common policy questions they need to answer? And what are the typical challenges they need to think about? And we created a whole tool as well for them they can use to create their own profile based on their needs to guide them through the process of the adoption of learning analytics. But the other important thing that we are seeing more and more is that we need to think about complex systems for the adoption of learning analytics. I would say technology and education, and more importantly, also to think about leadership as well. And what are the properties of that leadership? We had some work which moved into this adaptive complex leadership and the ways we need to think about not only administrative leadership, but also entrepreneurial type of leadership that can help any enabling dimensions of leadership as well. That should be happening inside of these institutions. And also, are you the leadership that comes from the academic or school leadership as well that is happening so that you have that extra level of credibility when you're promoting certain type of activities. All right, so that's my talk. Just a few quick remarks. We covered a lot of ground, I think. So one key thing is I want to say that basically we need to embrace and address limitation of data methods. Another thing is that yes, offers many great and good things, but education needs come first. I think it's a fairly obvious statement. And the final thing is impact can only be achieved by accepting socio-technical complexity of the systems that we are trying to work in. Thanks so much for your attention. I look forward to your questions.
Thanks, Dragan, for this wonderful presentation and also lots of insights in this talk. So here comes our question and answering time. So we can accept questions from the audience here and also questions online. For our online audience, please feel free to write your questions to the chat, and I will be reading out the chat questions. Okay. So,
you have already have 3 questions.
All right.
First question is how to reconcile accuracy and fairness to enforce some notion of fairness between prediction accuracy. Okay. Second question is hiring platforms play a role in generating data and as new learning strategy, basically crowdsourcing.
Yeah.
The third question is question-driven data storytelling looks very appealing. What's the main challenge designing such a dashboard?
Yeah, no, thanks so much. Very, very three thoughtful questions. First one is the reconciling of fairness and accuracy. I think that's a $1 billion question. I think for many, I don't really have the answers. All I can understand is the importance of us needing to reconcile these things. First, I think the most important thing is for us that we need to think about the acknowledgement of that bias and the extent to which that bias exists and is prevalent in our data. It has to come both from the understanding of what we know about our populations that we are studying already from the existing research, and also test our data itself. My view is that we don't necessarily always have to diminish, but I think when we are reporting certain types of things, and when we are also exploring the models, I think we need to understand both measure of bias across different categories, as well the measures of accuracy. And then eventually you let the humans to make that trade-off between the two, what you are getting. Where is that exact trade-off to be made? I think it's very potential. I'd speculate at this stage. In certain situations, you would actually like to boost that level of accuracy because the biases you may deem in certain circumstances is not necessarily so detrimental, but in other cases, it might be. So you want to have that kind of lower level of bias. So I think it's a really open question. Those who are looking into the research, I think they should be quite excited about the openness of the potential opportunities as well to look at as a exciting next research frontier to explore. With respect to the crowdsourcing, hiring platforms such as crowdsourcing play a role in generating data in testing new learning strategies. I think it's an interesting question. Sometimes you may not necessarily have sufficient participants, or it's not even morally acceptable to do certain interventions in the classrooms, simply because you may be worried that certain interventions may hurt your participants. But if you may have certain crowdsourced environments, then potentially that can be more relevant. What we do know, however, is that we need to check the extent to which that type of insight would be valid. What would be the ecological validity of that type of insight? Because it's one thing to test that on a population of the students with Hong Kong University, and in particular also subject areas. The other thing is when you kind of randomly try to sample, or even if you are actually far more like, promoting certain types of insights, it's still far harder to sample that population to the crowdsourced platforms. So what we need to do is more research on the validity, ecological validity of such insights. Some good work in psychology was done to demonstrate that some of these key surveys could be done to some of these crowdsourced platforms, but we haven't seen a huge amount of work in learning analytics and the broader field of education that can actually help us the extent to which this approach is critical. As well, you can see I'm kind of cautious here because I really all want to be tested. It's an exciting research question, but needs to be tested. And then the question-driven data storytelling looks appealing. What is the main challenge in designing such a dashboard? Well, there are many things. Like design is like art as much as it is science. That's really the key thing about any design project, right? So the first thing is like, initial upfront access to the relevant stakeholders, level of trust that you need to have with the stakeholders as well, who are willing to work with you. Really, the craft and skills of the people who are engaged into the design of the process, both in terms of the qualitative identification of the questions and the needs of the stakeholders, and then mapping that into the actual visual narratives, if you wish. So it requires a kind of very complex team. And the final thing is also validation of that approach and recognizing also individual differences of the stakeholders that they have. So you can see on each of these steps on the way, you can expect certain challenges, right? So if you have a good team and a high level of trust with your stakeholders, you can do magic with this type of approach. But if one of these things is not working well, the whole thing could be easily doomed as well. So hopefully I addressed your question, and happy to take any other questions that you may have. Thanks.
Thank you. Well, first of all, thank you for a very, very stimulating and insightful talk. I want to share some sorts of my thoughts and also end up with a question. I really appreciate, basically to me, you're telling us that in fact, learning analytics, like all other technological innovations, they are social technical in nature. So if we don't pay attention to that, it's not only may not bring outcomes, but it may also bring negative outcomes. And I like very much one of the questions that you raised: who takes responsibility for the, basically the outcomes of the actions that are taken on the basis of learning analytics? And I'm thinking, that's a very complex question. I'm just thinking, say, for example, now we do have self-driving cars technology. But what happens if the self-driving car runs into an accident? Whose responsibility? The manufacturer, the owner of the car, or who else, right? The software or the hardware or what? And so to solve the problem really takes a society and it's different aspects. So to me, it's that for that complexity, so I go back to the first slide that you started with, data, model, and transform. So you started by talking about data, but I'm just wondering whether data should be the starting point in that cycle. It could be starting with the model, or it could be actually starting with thinking about the transformation. And ultimately, where do people come in? And at the end of the day, it's whose voice. And if we want to build the systems include the people. And how can we make the technology transparent, as you said, and understandable and explainable, so that we do have an opportunity for democratic participation?
That's a really, really good thought. Nancy, I really appreciate it. I haven't really thought much about this last point you made about where to start in the cycle. I think partially because my perspective was always but with the way how we hop onto the game of learning and let's, oh, here's the data, the very point I was criticizing, right? And I think in retrospect, I think probably a good point would be think about transformation. What are our objectives? What do we want to achieve with the use of AI and certain types of things, or analytics in our case, in the data? And then try to think about whether we have the right data, whether we need other data, how we need to engage, what kind of governance structures we need to have around that data as well before we engage into the models, etc. One of the things that we decided in our work on Sheila project is, while these charts about the loops, they really look nice, they are also relatively constraining. So our work in Sheila basically decided to quit the loop of these 6 steps. So we basically map the context, identify stakeholders, etc. What we basically did is to lots of ethnographic work, if you wish, across more than 60 institutions in Europe. We basically find that many of these steps are happening in parallel. And some of them are happening basically, one after another in a completely different messed up order. So that's why we basically decided that it's the 6 dimensions that you need to think about. And I'd say that many of these steps as well could be relatively recursive. And I understand that, in a way, it goes against the nice representation of the problems that we are trying to think about, but probably is much closer to the messiness of the reality that we are dealing with, or that messiness really is the form of the complexity that we are actually supposed to be dealing with. And AI is just going to additionally complexify the issues that we are already having as a solution, but we know the roads to hell is often paved in the best intentions as well. So that's one thing. The other thing is that you also made a good example of the self-driving cars. We had this piece about the assessment in the age of AI as well. And the piece was also with Neil Selwyn, and his contribution was on the piece of relating to this black boxing of accountability. Meaning that many teachers say, well, there's this assessment engine. It's not me. Somebody made these grades by thinking there's some really good thinking about it. It's an impartial system that is doing that assessment, etc. But then in that case, if the assessment is incorrect or making certain systemic problem, who takes the responsibility? Is the school system who chose to use that AI system? Is the designers of the system? Is it the child itself? What is happening? So we really need to figure out, it has lots of repercussions as well in our education system. The only thing that is in education, even additionally troubling, is it's not an immediate big shock that happens. Like self-driving car killed a pedestrian several years ago in the US. It was an immediate headline and almost completely slowed down or stopped that line of research in many cases. In education, you don't get these huge headlines often. There was last year in the UK when they wanted to have a similar type of predictive model. that finally made it to the headlines. But these things rarely happen as a big shock, and they look as relatively mundane, but they are not, because they could potentially damaging somebody's entire lives.
First, thank you so much for your presentation. I read a lot of your papers, but today is my first time to read it in person. Very glad to be here. My question is very practical. So when we're talking about multi-model analytics, so I wonder, do we have any guidelines for some people who step into this field, how to decide what kind of data they can collect? I used to talk with a professor. He gave me very interesting answers. It depends on what you guys will have. If you have eye tracking, you use eye tracker. Eye track data, if you has biosensing, you use biosensing data. So, but I want to need some more conceptual guidelines. So, how do we decide the decision?
There are two things that probably could be 2 hour sources that you can start from that, the work we are doing. Obviously, that work is primarily in our group led by Roberto Martinez Mandolado. And it's also in collaboration with Simon Bakum-Shan at the University of Sydney. The first one is that we did last year's systematic review and published it at LAB, which looked into the scalability, sustainability, and ethicality. I didn't know ethicality is a word, but it is, of multimodal learning analytics. And so in a way that we speak about some of these things in learning analytics, that you want to basically have instrumentation room, but you have a limited budget. Like we, in some of our studies, instrumented large open school space with very expensive, super precise location capturing system from Finland. The school that costs like more than 100,000 Australian dollars to fit that whole space, and then eventually the big instrumentation. And then you think about, is that a sustainable approach as well? Can you scale that approach across many schools? And the final thing is the ethicality of that approach as well. Do you want every kid every day to be monitored all the time where they are located, because you can derive who they are actually interacting with, what they are doing, and everything. So there are all these 3 dimensions that they are tightly intertwined. You need to think about that. Provided to address some of these issues, we also recently published a paper that is accepted for publication that is in IEEE computing, basic computing, where we proposed a method that could be used for higher order, basically, multimodal analytics, so higher order skills that can be supported in the physical environments. So that basically the framework will guide you through the types of sensors and the infrastructure, the change software, the open source, also the whole infrastructure there that could help in many. You also need to think about, in terms of that sustainability and scalability, what kind of skills is needed. Can a regular teacher just come into the room, press the button, it's done? Or you need to have like an army of researchers outdoor, just basically support like a single class. It's obviously not sustainable and not scalable as well. The second thing is also we have this modeling part, which we, in our case, we use a quantitative ethnographic approach, where we are extensively using epistemic network analysis and trying to map these low level raw data are coming from all these data streams into the constructs we are interested in. In most of the cases, we are really interested in teamwork elements and collaborative problem solving, but we have other things. And the final dimension of that framework is also the kind of user interface part. So in a way, these 3 steps I was talking about, like the data, about the modeling approach and the transformation, is really, again, embedded into that framework, and if you wish, but framework itself gives you nice guidelines how to approach that approach. And we also describe in that paper as well several instantiations of that framework and how we went about it. Happy to pick up more conversation on this topic.
Thank you so much.
Pleasure.
I understand that there are still questions, but we are at the end of the time. We're exceeding the time already. So we have to make an end of this seminar. We welcome everybody, and if you have more questions, welcome to stay behind and continue to talk with our speaker. On behalf of our faculty and also the Center for Information Technology Education, I'd like to thank everybody for attending this very wonderful seminar. Thank our speakers. And also, I'd like to invite you to stay tuned from our news. We have following up the upcoming seminars in our series. So see you next time.